Still a second. Good. So just before lunch, I introduced the keyword continue, with which we could keep the loop going, but in one of those iterations, skip something. Yeah, we saw this in the example, but let's now move to an example with the grades. So open again N2 grades.py. If you close down your laptop before lunch and open it again, Python has forgotten everything. If you restart, so all your variables is gone. So before everything works again, then you need to make sure that you run everything. Import SK example 2. Everything that we did this week. You should run it again if you closed Spider for lunch.
No.
Perfect. So let's now move to example 3, using continue. An example of how to use continue. So example 3 shows an application of the keyword continue. Now we get a new goal. For example 1 and 2, our goal was just Lehulu Tamari watch, Mutter slash cement, Tamari get the final grade based on project grade and exam grade. Project grade times 0.4, exam grade times 0.6. Just the Hulu Tamari. Now we have a new goal. We want a list with only the high grades. We are just interested in a list of only the scores, the grades, which are kesemuanya balai. So we want a smaller list. We don't want Mutter cement grades. We want only the highest grades. And there can be several ways how you do it. But one way to do that is with the keyword continue. Because we want to loop through all Mutter cement Tamari. And if it's higher than Semanya, we want it to be appended. But if it's not higher than Semanya, we don't want it appended. So we could put continue as protection before it. If it's lower than Semanya, directly continue, do not. That's exactly what will happen. If you check this code, the following happens. Now we set E at 0, we make a Bado list, but only for the high grades, and then we are going to fill this list. So the loop is exactly the same, while E is smaller than the length of project grade, so 0 we are going to calculate the final grade. We are going to increase E by 1. But before we append this calculated grade, we are going to do a check. If this final grade is lower or equal than Semanya, directly continue. Jump back to the next iteration. So calculate for Tamari 0. If it's lower than 80, do nothing with it. Calculate it for Tamari 100. If it's lower than 80, do nothing. Only if it's higher than 80, this one is false, so it is allowed to append. In other words, with continue, you can put things, it kind of protects this code. Yeah? Anything we don't want, okay, we jump. Only the things we want will pass. So as a result, only numbers higher than 80 are appended. Only if it's higher than 80, this is false, malet continue is not reached. If this is true, we are reading a continue, we jump back. If it is false, we are not reaching continue. So now, let's do the following. Select example 3 and run it. And let's check this list. So now we created the list, final grade list high. Please tell me, centigrades in your list. So in this newly created final grade list high, centigrade. How did you check?
I just see the.
In here. Yeah, that's one way to do it. That is because we have spider. If we would only be working with Python and wouldn't have such a nice screen, we should have to use a function. So we can put and do length. This I. Okay, I put. Okay. Now a quick check is in this list, all numbers should be kesemuanya berapa? They should be higher than semanya. So we can quickly check that. We can say what is the minimum with that with the function min. We can check the minimum in our list. Final grade high. Now that's apparently semanya kehulat. So hulum salam indeed only numbers were added to semanya kehulat. For all the other numbers it continued, it did not append. Okay. Now I have another question. The first grade in final grade list high is semanya list. Je hey grade gemeen te maken. So we have Methoselassie cement temari. And these temari have the numbers 0 SK Methoselassie. Then we have a list with higher kuteros. Hulum ke semanya baka. Majority kuter is semanya mis ke 0 lit. Ke sintenya temari hey kuter.
What?
This grade, out of the Methoselassie cement temari, 0 SK Methoselassie. Je maan, je min temari, je hey grade, je maan. From who? From which student is this grade? Yeah, okay.
Yes, but
Can you explain the TAK to me?
I think that's what you're trying to.
That is my question.
How can you identify? Is there any name attached to the?
Well, that's a big question.
Or are you asking us the order, the rank of the student?
Yes, that is currently my question. That is because we now nicely have all higher grades of the highest scoring thematic. But it would then, of course, be very interesting to know which thematic were the high scorers. So my question is, how can we know from which student this grade is? Do you have any suggestion how to get to know?
I think in that here over in value section.
This one?
Yeah, there over. If we click double, he can display the.
And then we can start counting.
Yeah.
So we are going to look for Semanya Mystica Roulette.
Oh,
It's this one. Right?
yeah.
Yeah, and indeed, through the variable explorer, that's only possible in Spider. You can double click on something, then it opens in a separate screen, and then you can indeed start looking. So apparently, it's Temari Sadist. Yeah, just double check, final, grade list, Temari Sadist. Yeah, okay. So we now for under Temari. This would be, of course, a lot of work if we would do it for the Hulu higher. One other way to quickly look in a list is to remember that we have methods to list. Final grade list. If you did dot tab, you would see all the methods. And with the string you had capitalized in this one, with the list you had others. One of those methods is index. What does it do? Returns first index of value. In other words, you can look for some value and it will give you back the index of the value. So we could look for 85.02 and it tells us index 6. So arithmetic. The list, there's an if method. So that is enough. Yeah. Now I'm going to tell you a third method, and I think that one is the most nice. And the third method is to get to know the numbers for Hulutum Hayatamari. Haya Kutran, Haya Grace. Jenya Veligot is to also get a list of Haya Yetamari. Moet je maar je grid, min index. Hoe dat in je grid, min index. Is it so? Veligot person? What you need to realize is that here we are moving through 0 SK Mutusalasa Sabat Tamar. Each time we calculate a grade, and only if it's higher than Samanya we append. At the very moment that we append it, at that moment, Python also knows your min Tamari. Let me explain. We could just do the following. We have your final grade is high. We can also say student number high. But I'm going to make a new list in which I'm going to add all student numbers. In this one the grades will come, and in this one the corresponding student numbers will come. Now my only challenge is, how can I append the student number to it? Let's say I'm at 0. Now let's say I'm at Kuter's list. So I calculate the Tamaris list. The Tamaris list so that one is appended. At the same moment, I could also append the student number. Do you see something here which is the student number? Le temarische list je heet Semanya Amis Zero, right? So we want to save Semanya Amis Zero, but we also want to save Kuter's list. Kuter's list yet. Final grade.
Yeah.
Sorry? Yeah,
I.
Yeah, exactly.
Yeah.
I is the student number. At the moment that Kuter Semanya Miske Zirulet, I is the list. So we are not only going to save the grades, but we are simply also going to save I, and that will give us exactly. There's only one small problem. Here it is 6, then we turn it into 7, and then it is still appended. The one that is appended belongs to 6, but at the moment of appending, E is already 7. Oh, that's easy to solve. We are going to append E. This will solve it. So if I run this again, I can check final grade is high. Oh. Of Hulatanya Kuter is Semanya Ant. Sostanya Kuter is Semanya Ant. Kemintamari now, well, I can check that. By checking. Students? No. Hi. Hulat. Kutamari high, let's check. Look. Again, do not focus on this code and how to get a student. The most important lesson here is that the more you practice with doing, the faster you can come up with solutions for questions. Yeah. Now, I could come up with a solution because I had already thought earlier about it, but I only thought of the solution because I practiced earlier. So always realize if you want some information, try to look where is this information already available. And if this information is not yet available, then maybe you need to create some other list. Good. This is just to show you limit negative of tools. And most importantly, this is to show you that everything that you want, all information that you want, you need to code yourself. Yeah? We took higher maximum grades, and then suddenly we realized, oh, we're interested in your mathematics. Python does not say that for you. No, you have to program it yourself. Everything that you want, you have to program yourself. So the sooner you practice with the tools, the faster you are becoming translating Polyglot into math. Okay, so this was an example of the use of kata and protects your code. If you want something to happen only once, well, put it behind the protected barrier. Before that, we saw break that attack breaks out of it, or just use the condition. I just do some quick questions before we move into the second types of loops. So far, we discussed while loops. We'll move into for loops, but first I have some questions to check whether you are still with me. Yeah. So stop typing, because the typing is not the important. It's about the principles. And we're going to check whether you are following the principles. So consider the following code. E is 0, I is 0. While I is 20, smaller than 20, print I. 4 simple questions. What will be the printed value of I in the first iteration?
I is 1.
0.
0. Yeah, because we started 0. What about the fourth iteration?
3.
3.
Check the code again. Majority iteration it prints 0.
Yeah.
What happens after that? Where?
Nothing will happen.
Nowhere E is changed. It prints 0 and a loop. Next loop. Prints 0, 0, 0. Yeah, there was no. Yeah, so anything that you want to happen, you should put that there yourself. Okay, so in the fourth it's 0. How many iterations will there be? Depending on how fast you are. Control C. Yeah? And the final printed value of E will of course be 0. But now this one. What will be the printed value of I in the first iteration?
0.
0. And in the fourth?
3.
Now it's exactly. How many iterations will there be? Higher. Yeah. Okay. What will be the final printed value of I?
Asrazde.
Exactly. Yeah. Higher iterations, 0 less constant. So that's all quite logical. It's only the minus 1. What about this one? What will be the printed value of I in the first iteration?
Asrazde.
No, majority iteration.
It's 1.
It's 1. Yeah. And that's just, if
Okay,
follow
it's
the code
equals
step by
to.
step,
Yeah.
It enters the loop. Is it allowed? Yes, it's an E is 0. It's smaller than 20, yes. But the
Yeah.
first thing that happens, it is turned into 1. And then it's printed. In other words, 1 is printed. As Aratania iteration, what is the printed value for Aratania? How many iterations will there be? Now, It's still 20, yeah. Yeah. We will check that in a moment. But what will be the final printed value of I? In the higher Tenya iteration.
Now it's 20, it begins from 1.
It begins from 1 up to 20. We can just check it step by step. Well, the 8, 9, 10, that will be fine. Then E is 19. It's still allowed to continue. Yeah, the 19 is printed. Still smaller than 20, okay? Turn it into 20. 20 is printed. Not anymore smaller than 20. Stop. Yeah. So, yeah. This is Python does nothing magical. The only magic of Python is that it does things very fast. Yeah? But it follows exactly the same logic as we. If we just follow the logic, it just does everything step by step. What will be the printed value of I in the first iteration? You're worrying about this, but that's
Dot 11.
No. I is 0. Well, I is smaller than 0. Check. If I is 10, oh, okay. Print I. Print 0. Nothing happens with this because it's not 10. So 0 will be printed. What's the printed value in Aratenia iteration? Source.
What is the use of writing if I is equal to 10? Why do we use it?
I put it here to confuse you. Okay. And that comes to this question. How many iterations will there be?
10.
Yeah, let's
Including
follow.
0.
Acertenia iteration, we are printing 9.
9. Yeah.
And then E will become 10. It will start Asra Andanya iteration. E is 10, I is 10, then it will break.
Yeah.
So it's Aser Gemash iteration. Yeah. It will stop in its Asra Andanya iteration. Yeah. So what will be the final printed value of I?
9.
9, exactly. Yeah, because before 10 is printed, it's already broken. Listen up. Yeah. This is of course stupid. Like this is not useful code. But the previous code was also not useful code. But this simply shows you how to use what break does. Yes. Good. Now, having checked all of your knowledge, let's move right away into the for loop. And I will introduce all relevant aspects of the for loop, and then again check a bit of your knowledge, and then move to examples for the SCAN. And then it's getting a bit complicated. And that is not because for loop is so complicated, that is because we're going to put a loop inside. And then it's really getting into it. But let's first start with introducing a for loop. A while loop loops while some condition is true. Just as long as it's true, it keeps on looping. You have to do something about the condition or behavior to let it stop. A for loop is very different. A for loop, let me first tell it in words, and that sounds complicated, but then you'll see the answer. A for loop loops for, that's why it's called for, some given loops in a sequence. It loops over a certain sequence. Last week we saw some sequences, like a string or a list or something. It looks like this, for some variable in some sequence. The amount of iterations will be equal to the length of the sequence. And each loop or iteration variable will be the next element of that sequence. Jij hebt zo Engels en now? Let's look to an example. In module 1 we saw 3 sequences: string, list, and range. So let's start with a for loop and a string. Do the following. You can set Meister at hello, and then type this in the script editor and run it. So Meister is hello, and then for e in Meister print. We can move back to M2 code, and we're going to make a for loop. This is the other one, or you can use the rest in the script editor. So in for e in Meister, that you can use. Yeah, so this is fine. Yeah, lekker doen. Yeah. So for my string is hello, that's what you can do here, but for the other one, is yellow, so that one is. And to go, I'm not going to part that you need to write here is the yeah. Okay, and if you've done that, run it and tell me what happens.
Hello.
It prints hello,
Hello.
indeed, but not as a whole word, but letter after letter. And that is exactly what all these English Dutch try to say. We loop over a certain sequence or collection. In this case, the sequence is a string. So we're going to loop over hello. And what this leads to for e in Meister, which is hello. So actually there's for e in hello. Then it's going to loop over hello, but the first iteration, I will be majority element of the string. The second iteration, I will be the second element. We zitten, and it will stop when it's reached the end. So it will simply have amiste iteration, Silla, amiste, never. And each iteration, I changes itself automatically. We don't have to say I plus 1 or whatsoever. No, I will just be every time the next element of this sequence. So that is entirely different from a while. So this code takes 5 iterations, the length of my string, and changes I with every iteration. Just what we see, and now we say please print it, and therefore we say majority iteration, amazing iteration. It is printed. Now, this was the first example with a string. Much more useful is it to use it in combination with the function range. While for cement, we saw that with the function range, you could quickly create a range of integers. 0 pescar, higher, or asset pescar, higher steps of bullet. Start, stop, bevindt, comma, step. To see all the numbers with our own eyes, we have to turn it into a list. But in the range itself, already all numbers are there. So if we want to loop over a range, we can say for e in this range, and then E will be all the numbers of this range. 0 is kind, 0 is kind, 0 is kind, a million. So that's a very fast way to let E change. So using the function range in the for loop is often much more useful. Range 20 is a sequence of 0 up to and including 90. Range ant, haya, comma, ulet is a sequence of ant up to and including 19 with step size of ulet. Yeah, that's just how the function range works. We saw that last week. So in a very fast way, we can print the numbers 0 as recipe by just typing this. So you can also type this and run it and see that it works for E in range 20. Print E.
Yeah, next one.
Now, you get the number 0 as constant.
No.
And now we simply print E, but of course we can do a lot of things with E. We can use it as index for our list. We'll do that later. We can calculate with it. Now we simply print it. So as you can see, indeed, all numbers are in this range. And if we force a loop through it, it will force all these numbers out of line. Numbers 0 is higher. I already said it, but I want to stress it again. The big benefit versus while is you do not have to change I yourself. The for loop does it for you. Here we only say print I. There is no please turn I into this. No, I will simply be step by step all the elements in this range, or string, or whatever collection you might have. So that makes the for loop very powerful. You don't have to worry about programming the end because it will automatically stop as soon as the sequence or range is finished. If you have a sequence of 100 million quarter, then you will have a for loop of 100 million iterations. You cannot have a never-ending for loop because there is no never-ending sequence. I want to go one step deeper. This morning we already saw nested if statements. If statement, inset, if statement, inset. Same we can do with loops. So of course we can also put loops into loops. We just need to make sure that our indentation is correct. So for example, do the following: for E in range 5, print main iteration plus string of E. And inside that we say for J in range 3, print sub. Yeah, so we are going to put a for loop inside a for loop. For E in range 5, print main
Amen. Is there any way to change this background into white?
Yeah.
So it's spider dark, but you want the normal spider. Okay. Save everything.
Yeah, I think most of you worked it out. Some of you run into errors and solved it, so that is even a better lesson. As you can see, it does exactly what we expected to do. Range 5 minus 0 SKRat. It prints main iteration 0, then it encounters another iteration. And so then it first needs to finish this iteration before it moves back to the main iteration. That's exactly what we see here. We are in the main iteration and then quickly 3 sub-iterations, then it is allowed to move to the next main iteration. So in the combination of all of this, you can make very complicated sequences of code. Quick question. I think I saw that someone screamed. What will happen now?
Not working. It's not running.
It will?
I don't think it's running. The mission right
No, there's no error here. This is simply allowed. Yes. So what happens?
It starts with iteration number 0 up to 5.
And
Then after it starts the second up to 3.
Because now this one is not part of this anymore. There is no tab. It's simply new code. And so this is a loop. The only thing that happens inside each iteration is this print. Okay, it will do this 5 times. Yeah, exactly. It only prints this. And when it's finished with this, then it continues with the code. Oh, that happens to be another, and that is 1, 2, 3, 0, 1, 2 of the sub. Yeah. If you want this to be sub, you need to make it part. And so mind your indentations. How to quickly resolve it? Select both and hit tab, and they both go on top. Yeah. So if you see it as a family, now this for loop, the sub one, is your main lich. If you do it like this, it's just the main heat. Yeah, just to let that loose. Now, so that differs quite a lot. Yes, that brings me to some other questions to check whether you are still with me, and after that we are going to move into the Kabat examples. Yeah? For example, for E in range Salasa print E, what will be the value of I in the first? Sorry, I sometimes say E in Dutch and yeah, this is E. In Lithuania, this is I. Mix it up sometimes. But what will be the value of I in the first iteration? Out of range Salasa. Majimari element in the 0, exactly. Yeah, Majimari element of the sequence will be the first iteration. So what will be the value of I in the fourth iteration? 3. Yeah. How many iterations will there be?
30.
Salasa. But what will be the final printed value of
As
the
taken.
That one is high. Yeah? When we started at 0. Yeah? So the for loop is very clear actually, because if you say range Salasa, you can be sure there will be Salasa loops. So if we want Muto Salasa Sapat loops for Automari, we can just say for range E in. Now if we want Muto Salasa Cement loops, 0 is Muto Salasa Sapat, we can just say for E in range Muto Salasa Cement. Or for E in range length of project. Yeah, so that is, range is very powerful. What about this one? What will be the value of I in the first iteration? Did you say 10 or 20? 10. 10. That was his 10.
12.
Now the first keeps.
Twice, right? But
Yeah, but just in the first iteration, it's just 10. Yeah. But what about the fourth iteration? 16, yeah, 10, 12, 14, 16. How many iterations will there be?
5.
5. Macherisha quotient? Asracement, exactly. It stops Kahaya. Very good. You know your range. What about this one? For E in a list of something, what will be the value of I in the first iteration? And in the fourth?
11.
How many iterations will there be?
5.
What will be the final value of I?
12.
In other words, you can loop over any collection. Range is often used, but if you have a list of Uptgoeder, if for some reason you want I to be 5, then 9, then 2, then just make a list with Uptgoeders, and it will just move through that list. You can loop through any collection. I think this is the final one. For I in hello, everybody print I. What will be the value of I in the first iteration?
8.
Capital 8. And in the fourth?
L.
And first or the second? How many iterations will there be?
Yeah.
What will be the final value of I? As recidivist. Yeah. If you said as rarat, I think you only counted the letters and then your final value would be Y. Right? But exclamation mark is also a character. So final value will be an exclamation mark. But as recidivist, look, no, because a space, as humans we see a space, but for Python it's just another character. If you check the length of this, it will be as recidivist. because a space also is some length. No? Space is just like any other. So as this the Lykanov Macerisha value will be exclamation. Oh, I had still another one. What will be the value of I in the first iteration and of j?
Zero.
Zero, yeah. Nothing's changed. It's just we start in a range 0 as per 10, the memory iteration is over 0. What about j?
Zero.
0. Yeah, exactly. And now it becomes a bit dubious because it depends what you call iterations. In the fourth iteration, what will be the value of I? Yeah, the fourth main iteration. What will be the fourth print value?
For what? For I or J?
Hoe let het? It will print I and then J and I. So, Aretania print. What will be Aretania print value? So, no. But that's maybe because the okay is a bit ambiguous. For E arranged, it will print 0. That's the first line. Then it will move into it. It will print 0. 1, 2. So the fourth printed value will be 2. And it happens to be J. How many iterations will there be? That depends a bit on how you look at it. Of course, 10 main iterations. Inside each main iterations are missing sub-iterations. So some people might say Hamza iterations. What will and the final value of I and J?
Nine.
Of I and of J?
Four.
Not Hamza's iterations. Of course, Arad. Yeah. But there will be Sosa lines printed. Every main iteration there will be one printed of I and 5 of J. Yeah? So no fixed answers on this one, but just to make you aware what happens. Yes, that was the build-up to the more interesting examples. Because we are going to use a nested for loop to create a group average. And before we are going to move into that example, I want to do something on paper. So I'm going to clean it. I'll empty it here again. This is a print screen of all the grades. Are these numbers visible or not? Visible? Connect? Okay, can you see it? Jacob center?
0, 5, 6, 2, 4.
Perfect. Okay, then we can work on it. Because this is a print screen of all the numbers that are in our database. Yeah? Semantic. And now we have the following task or wish. All these students were in groups. And we at this moment do not know yet the group synthetic. Here we see 2 times group 5, but maybe later on there are also some. Our goal is to get averages of the final grade per group. Yeah, so we want to know what was the average grade for group 2. What was the average grade for group 5? Now the question is, if you have this in front of you, and you would have pen and paper, how would you calculate, let's start with 1. How would you calculate the average of group 2? If you were allowed pen, paper, and calculator. So we are interested now in the average of group 2. What would you do?
I look group 2 members
Okay, so you
from
will look
each
in this
column.
list, group 2. Okay, so the first one I already see. It is 0.6822. Any more?
In the second 0.585.
0.585.
0.4968.
0.4968.
0.5419.
0.5419. So we have this one.
No, nothing is left.
542.
0.7.
5.
753.
Oh, here you have 0.585, but there's also 0.5412.
Yeah.
One.
But I want, that was
0.5753.
753.
0.5753.
Yeah.
Lelu? No others?
Yeah, it's
Okay. So what you are doing is you are scanning this list for group 2. If you find group 2, you take that number and you put it on here. When you are finished with taking all these numbers, I think you will do the sum, and then after that divide it by the amount of numbers, right?
yeah.
So this is what you would do on Python. Now Python is no magic. Python does exactly the same, or at least if we ask Python to do it, it will do exactly the same. Only the benefit of Python is it can do it very fast. But Python is not checking the list and at one time picking out all the 02 numbers. Now Python also needs to go through all the things and check is it G02 or not? Is it G02 or not? Beyond G02 now. Take the number, save it. And if you move through all numbers, Barunas Lega G02 Willem, then start taking averages. That is exactly what we are going to do in a loop. Because that's exactly what we can do in a loop. Loop through everything, collect all numbers, and when you finish looping and collected all numbers, then take the average. And that you can do for G02. And after that, you will do it for G05. And after that, for G07. Right? That is exactly how we should would do it, and this is exactly how we will let Python do it. So keep this in mind, because always, almost always, I think, programming comes down to not something magical. It simply comes down to how would I do it logically on paper, which steps would I take, and which tools in Python do I know that do these steps. Put it on paper, put it in. So let's look how that works. We're going to do it in 2 steps. Nested for loop for group average. That will be example 4. With both loops and if statements, we can make a list of average values. Look. Now we're going to do that in 2 steps. For Python, actually, the first step is to create a list with all unique group names. And then the next step is for each of these group names, G02, G05, etc., loop through the whole list, which cockroach belong to this group, and then take the average. So the next step is for each of those group names, loop through all the grades, but only take the grades matching with the position of these group names. take the average of these grades. So per group, we look through all the grades to find it, or who look good, and then we look through all the groups.
Where is my?
Oh yeah, sorry, I forgot already. So the first step is to create a list with all unique group names. Let's do that as first. So if you open M2 grades.py, we'll move into that first step. Our first goal is to get to know mijn groups aan. We do not even know yet center groups. We only know Mutter, Celeste, Cement, Tamari aan, and all of them are in some group. And we have saved all the Mutter, Celeste, Cement groups into group names. Here we see G2, G5, G5, G. Now, how does it work to get the unique group names? That's what we're first going to check. The first step is to create a list with unique group names. First, of course, we create an empty list. In this one, we are going to collect all unique group names. We already have a list with Mutter, Celeste, Cement group names, but we only want the unique ones. And then we will look through the whole list of group names. This is group names all. So for E in range, length, group names all. So E will, what is the length of group names all? Group names all is Buttemari min group name. Buttemari min?
No, it doesn't.
Exactly. So the length of group names all is also Mutter, Celeste, G2, G5, G5, G5. So, in this one, what is the first value of I in this range? 0. What is the final value of I? Exactly. So that's exactly what we need. Yeah? So that is a good start. That's our goal. We will look through the whole list of group names. And now comes the magical part. It's not so magical here. Every iteration, it is checked if a group name is already in a list with unique group names. If that's the case, it's not appended. And we use a tool that we saw previous week. With the keyword in, we can quickly check, is this in the list? Majority iteration, I is 0. What is group names all 0? G02, majority group. So it's going to check if G02 is in group names unique. That's false, because group names unique button. Okay, so continuous not reach. In other words, group names unique don't append group names all E. If G02 is not yet in a unique group, append it. Okay. E becomes 1. What is group names all 1? You can check it. So what is 1?
G05.
G05. Okay. So if G05 in group names unique, oh, not yet, because there is only G02 in there. Okay, append G05. Then we come at 2. Group names all 2 is also G05. If G05 in group names unique, yes, we just added it there. Okay, then continue, do nothing. So we move through all our Mutter, Celeste, Cement group names, and only if every unique one we put in our unique. Right? G02. Okay, put it in. G05, put it in. G05. Oh, already we had it. Continue. G07, G09, etc. So in this way we loop through it and we get all unique group names. Every iteration it is checked if a group name is already in our list with unique group names. If that's the case, it will not be appended. This results in that only names are appended that are not yet in the list. Okay, so now let's run this code. Run group names unique. And tell me syntax group A. In other words, what is the length of group names unique? Syntax append.
Uh, 29, 28.
28.
Yeah.
If you check the length of group names unique, we indeed have higher semantic group. Higher semantic is a group was appended. Okay, so now we know min groups, and now we can really move on to getting the average per group. So the next step is getting average grades. And just to make it a bit easier, we will first check how to get it for one group. Yeah? And that is exactly what we did on the board here. And the code for that is here. Second step, getting the average grade for one group. And so, just for clarity, we do it for one group, and when that's clear, we can do it for groups. Firstly, we set the group name. Group name is group names unique 0. What is group names unique 0? What is Mageia element of group names unique? Which one?
G02.
G02, exactly. Because that one was the first event. Okay, so group names become G02. Then we create a BADO list, the group grade list. In this list, we are going to collect all G02 grades, just like we did here. In total, we found 5. Hopefully, or let's check whether we can also find 5. Yeah? BADO list. And then we are going to force Python to move through Muto, Selasa, Cement, just like what we did on the screen. Python will not do it. For J, in range, len, group name. So, range 0 is going to do Selasa. If group names all J equals group name, group grade list dot append final grade list. This is exactly what we did. I think a bit clearer here. So each iteration, we're going to look through all group names and check whether it belongs to the group we are busy with. Mageia group name. Is it group 2? Yeah. Okay, if that's so, then append Mageia grade. Uletenia group name. Is it group 2? No? Okay, nothing. Sostenia. Is it group 2? No, nothing. Rosetta. So it loops through everything. Bihonus, Z, group 2. Okay, then take also Yehei grade. If group names all higher ant, group 2 now, take grade higher ant and append. Yeah? So check whether it belongs to the group we are busy with. If that is the case, then append the corresponding grade to our list of group names. So this is exactly what we did on the screen. We moved through everything with our eyes, and be honest with G02, take it, save it in a list. Okay, we let Python save it in this list. If we moved through all Muto grades and group names, okay, then the iteration is finished. Quick question in between. The final line, group average, does it belong to this loop? No. Exactly, you're already nodding no. And that's exactly what we want. Yeah? group, we want to collect all grades, and then when the loop is finished and we have all group 2 grades, then we are going to take the group average. And the group average is, of course, the sum of this list we filled with all the grades divided by the length of this list. So after the loop, we take the average of the collected grades. So that is how we do it for group 2. That happens here. Define group 2, make Bardo list through all grades of group 2, loop through all group names, behomes group 2 now, put your group 2 grades into the list. If you are finished, then take the average of this list, the sum divided by it. That is for group 2. We can simply let Python do that for all the groups. And that's exactly what we are going to do. Next step, getting average grades, but now for all groups. And that happens here. Second step, getting the average grade for all groups. Now, the steps in that are, we create an empty list in which we will collect all highest symmetric group average. Per group average grade. We loop through our unique list of group names. Higher symmetric group names are. So, group names unique for E in range, then group names unique. 0 is the highest. And what do we do each iteration? Group name 0, group name 1, group name 2, let's go group name highest setup. We take the group average. This code is exactly what we saw earlier. This code is exactly this. Here we did it only for group 2. This all we just put into a loop that loops through group 2, group 5, group 7, group 9. So for group 2, find all grades, take average. Okay, if you're finished with that, for group 5, do the same. For group 7, do the same. So each time that you take the group average, then append this group average. Okay, that's a lot of words, but I hope you're starting to realize that what we do here, if you directly would like to code it, it's difficult. But what happens here is exactly the same as what we did already. We scanned through all the grades. Python can do that as well, but then in a loop and very fast. We took all the grades. Python can do that as well, append all the grades. We calculate the average. Python can do that as well, take the sum from the We would like to do that for group 2, then group 5. Well, Python can do this as well. Take first group 2, group name is group 2. Second iteration, group name is group 5. Good, let's now run this and see what we got. But to summarize, we nest the loop for average per group into the loop for moving through all groups. So this is an example of an application of a nested loop. We move through the highest symmetric groups, and each of these iterations, we move through all the grades to collect all the grades for the majority, all the grades, all the grades. So, multi-symmetric iterations within highest symmetric iterations. Okay. Run the code and check the new list average grade list. And after this, let's have finish Guna rest. But you can now run this average grade list. The second step full. F9. And now one question for you. Two questions. What is the average grade of group 2? So based on what we created an average grade list in which our highest symmetric is in. Now what's the average grade for group 2? Let me ask it differently. Average grade is 0. Is slechtheid geadresseerd. Een groepje heet average. Min group, Majimaria group.
G02.
Exactly. And we follow the order of group names unique. 0. So now I have the following question to you. What is the average grade for G08? Yeah. Okay.
G0 Great.
Now, this needs to be okay. You're looking for G08. Did anyone find already? I at least another. I think you're looking for G08, right?
Yeah.
There is a faster way to look for it. What you can do is group names unique dot index. This morning I quickly also showed. This tells you the index because you want to know Centennial index. You want to find group 08. Goed, er zijn did you find it already? But this will also tell you the code. If you're looking for G08 in there, this will tell you what you take. Let's check. Yeah. So then we know that average grade is then must be G08. Yeah, Krishna?
So
We know that index 0 is G02. So Maria average grade is also belonging to G. We want to know Syntenia group was G08. Apparently that is Acertenia group because the index is 9. A quick way to find the index is with the built-in function index. If you're looking for G08, you can look with index G08, it tells you 9. So indeed, Coulter 9 gives us G08 in group nature unique. So the average grade of group 08 will be also Coulter 10. Now, previous week I told you that all individual steps almost always can also be put into one step. So here we have 9, we are using 9. But what is 9 actually? This is also 9. We're actually not interested in 9, we are interested in the grade. 9 is just a step in between. This calculates 9 for us, and that one we use directly again. That's very nice because now we can do it for every group. Group 15. I hope Syntenia Coulter, but Python will calculate it for me, quotient, and then Python will directly use it to get what was the average of group 28? 72. Yeah, so practice, 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 and just think, indeed, first it's good to do it in different steps. If you want to know the group, the grade of group 8, first step is Syntenia group number, find the index. Second step is use the index. After you've done those two steps, most of the time you can realize, okay, 2 steps, I can turn them into 1. That's what we do. Good. I think now is a nice moment to take Dennis Boenhuyt. Yeah, because we need to stay sharp as well. Azrullah Deka beginnen. We are now busy with logically challenging method. Just before Yabuna left, we made an average per group, and we saw some quick tools how to get more information about it. But the basic idea is get a list of groups other, and then per group calculate the average, save it, calculate the average, save it, and loop through it. It's exactly the same as what you would do on paper. So if we would quickly go one step back, if we would look to this list again, but if you would not want the average per group, but you would want the maximum, the highest grade per group. What is the highest grade for group 2? Yes. So then again you would scan all the grades, you would save them again, 0.682. Okay, what's the maximum grade for group 2? Based on pattern.
75.
75.
Yeah, 0.3.
How did you find it?
By looking.
Looking, yeah. I think what you did is indeed looking through it, and then the first one you find is 0.68. Then the second one you find, if you scan carefully, is 0.54, but it's not relevant because this one's high. So we can directly forget. The other one you find 0.58, okay, also ignore. 0.49, ignore. Then 0.75. 0.75 is actually higher. So throw this one away, this one. and then scan, keep on scanning, and if you find no new grades, just keep the highest, and that's your maximum. Now, exactly this we will let Python do if we want to find the maximum grade. So we saw how to find the average grade. Quite similarly, we can retrieve the maximum value per group. So that's example 5. It's very similar. We're going to loop through group names unique, and we'll start with group 2, for example. What are we going to do for group 2? We set max grade 0, and then we let Python scan through the whole list. In the subgroup, we add one condition. So first we check, is this group 2? If not, okay. But if this is group 2, then there is a second condition. Is the corresponding grade also higher than max grade? Well, at the start max grade is 0, so the first grade we find is 0.68, it's higher. Okay, yeah, same group, it's higher than 0. Then change max grade from 0 to 0.68. Continue. Is it group 2? Yes. Is it higher? No, it's only 0.49. Okay, do nothing. Oh, it's only 0.55. 0.75. Group 2? Yes. Higher than 0.68? Yes. Okay, then change the 0.68 into 0.75. In other words, find the grades and update the grade if you find the higher one. And if Python moved through all of them, looped mutter symmetrize, then doen het je max grade we can append to max grade list. And so this is exactly what you would do on paper. Scan through the list, get all grade 2 grades, group 2 grades, only keep the highest. Okay. So we can run example 5. We make a Bardo list, we look through all the group names, and for each group name we find the highest grade, and we append it, and then we move on to the next group. Let's run it. Now, what is the highest value in max grade list? Out of max grade list, the highest value. We can check that with the function max. So out of all maximum grades, the highest number was 98.76. Out?
Yeah.
Yeah?
Yeah.
Yeah. Okay. Yeah, max grades list. Yeah. And so we have highest cemented maximum grades per group maximum grade. Out of these highest cement, the highest was 98.76. Now, if the question would be, kan mijn groep me bellen? Then we could, of course, first try to find in max grade list what was the index of this 98.759. In other words, what is the index of this one? Centennia footer was the maximum grade. What is the index of the maximum grade? Oh, what is
Mix.
Okay, quick check. Max grade list 23. Yes. Okay, so group names unique 23 is apparently high. So in group 21 was the student with the highest score. Group 21 was Kuter Hayes-Sost, Max Grevis Hayes-Sost is 90. So again, these are different steps. We can take them all into one. Group names unique 23. What is actually 23? This is 23. Just as an example. What is the maximum grade? 98.76. Centennia grade number. How does Max grade this? Max grade of index of this. What was the corresponding group name? Okay, group names unique. Heidsels. Replacing the different steps. Yeah.
The problem is when I try to run
Okay, let me quickly check.
it doesn't know this one yet. It didn't know the previous question.
This because we are allowed to replace everything in it. Okay. Quick question, or maybe not that quick, depending on how quick you answer. Just watch my screen and tell me what to do. Do not do this yourself. We will be only working with my laptop for the moment. I copy this, but now my goal is to get min grade list. Here I get bug group maximum grade. Now I want bug group minimum grade. What do I need to change here? Yeah, I could change this to min grade, but that's just a name. If I change that, then I should also change it here and here.
Main grade list will update.
Mm-hmm. Now, and this one. So we got the maximum grade to take the first grade. Then if we got the second grade, we checked, is it higher? If not, okay, ignore it. Only if it's higher, replace it. We get a maximum grade if we each time check, is it higher? Then take it. How do we get the minimum grade? So here I say if it is group 2 and the grade that you find is bigger than the previous, please update it. If it's bigger, update it. And then finally we get the maximum. So now I want the minimum. Smaller, actually.
Yeah.
If the next one you find is smaller, please update. Okay. Let me quickly try this. Error, yeah? Let me check. With the current min grade list, I only get zeros.
Yeah.
Why?
Because it's equal to 0.
This one is set to 0. And then we're checking, oh, the grade that you find, is it smaller than 0? No, it's never smaller than 0.
Yeah.
So it's keeping 0. So what should we change this to? 100. Example. Yeah. 100. We start very high, and then the first one we find is 68. Is it smaller than 100? Yes, okay, update then 68. The next one we find is 49. Is it smaller than 68? Oh, then update it to 49. The next one is we find is 75. Is it smaller than 49? No? Oh, then do nothing. Yeah, so we just reverse this logic to get the minimum. Okay. So let's try this. This looks much better. Indeed. Now again, do not focus on this code. There's no need to have this code. I'm just challenging your logical thinking. And the idea is not that you now directly know all the answers and otherwise you do not know Python. The idea is the more that you work with Python, the more your logical thinking will be challenged and the more you will learn to apply it. The basic idea is think, what is my goal and what are the steps to my goal? If my goal is I want a minimum grade per group, then the steps towards this are let Python move through all grades. Each time when it finds a lower group, save it. Now, if you've drawn that nicely on paper, then you can move on to the tools that you need. But the tools itself are not so difficult. It's not so difficult to type for range, how does it work? Not so difficult. Len, how does it work? Not so difficult. The challenge becomes combining. Yeah? So there's absolutely no sense if you have this code, because then you know how to get minimum grade. You need to know the tools in order to apply it to your own flow data or weather data. Okay, I think that's enough of challenging your brains. Let me quickly shift. Maybe let me go to shift order. Yeah, I'm going to reshift the order of finishing this module. I'm now going to take my time to speak shortly about errors. Kazambawala, I will introduce an assignment that you can do in your own time. Kazambawala, depending on the amount of time we still have, we'll move to example 6 and 7. Because the most important things of loops we have already seen. You now know the structure of a while, you know the structure of a for. And you saw some examples of what you can do is you put a for loop inside a for loop. Look through the group names and look through all the grades. Well, group names. That was one example. Now, example 6 and example 7 are two minor additional applications which we will come to after I do this. First, I want to discuss errors, so you can sit back for a moment and charge your brain again. Because errors and exceptions. You've already seen a couple. I think all of you already have seen some red on your screen, run into an error, something went wrong. Code can contain errors. If Python realizes there is an error, an exception is raised. You get some error message and the code stops running. You might think that's a problem. That is a problem because your code stops running. But actually, those are the most easy ones. Because Python sees it's an error. It warns you. Much more dangerous are the errors that do not cause the code to stop. There can be errors that Python just thinks Ulum Salam, but actually it's doing something very different than what you expected. And that one is much more dangerous because you don't get the warnings. So the broad two types of errors are syntax errors and semantic or logical errors. So first of all, syntax errors. If you are not using the correct syntax, Python grammar expression, you create a syntax error. For example, if you not end an if statement with a colon, if you say if this condition and then directly write your code, no, it should always end with a colon. Yeah? Or you can mistype keywords. So, you could, for example, type will instead of while. Those are examples of syntax errors. Those are very easy to solve because it will simply say syntax error or I do not know the name will or whatsoever. It will normally also point you to the line where it went wrong. So usually these errors are recognized by Python. You will get an error message. Semantic or logical errors are of a different type. They are much more difficult to spot if you have implemented some wrong logic. Very simple example. You might want to have all numbers of 0 up to and including 25. But how? If instead you would use value bigger than 0 and value smaller than 25, you would make a logical error. Because based on this code, you would only get the numbers and SK and including higher adat. This is still a very easy one to spot. But this is an error that Python does not see as error. It will simply give you and SK higher adat. Only maybe if you are not thinking clearly, you might expect the other numbers. And these are very dangerous. If you forget that counting actually in Python starts at 0, and you implement that on your yearly data, then you might be publishing, you might think you are publishing data from January, April. But in reality, maybe you are using December, March. Python will not give a warning. So you need to regularly check, is this really the data that I expected? So semantic or logical errors usually do not give error warnings. Your code simply runs, but does something different than what you planned. Check for such errors by often testing your code or adding print statements. And so you can add a print statement, print E, and then you see, oh, the first I is actually 1. Where did I program it wrong? Because I need the first one to be 0. And often test your code. Check just randomly Hamza Tenya Kutter that is calculated. Is that the same as if I calculated by hand? So this is just checking prior and back. Good. Those are the semantic and logical errors. But about the errors that pop upon your message, I just want to pick out the most common ones. Because mostly, if you just read the error message and you know the error now, it will already very soon point you to the solution. So the most common exception types. A very common one is 0 division. And that one is very clear. You try to divide by 0, but that's not allowed. Of course, 10 divided by 0 will give you that error, but also, if you create some Bado list, we did that, and for some reason this list does not get filled, because maybe you put the wrong condition. And then you take the average of this list. Well, if it's a Bado list, then the sum is 0, the length is 0, so you get also a 0 division. Python will not say error this list is Bado. No, it will say 0 division. The second one, I think a couple of you have already seen, is an attribute error. You try to use or access some attribute that Python does not know. Attributes we saw already part of cement. For example, dot capitalize, dot replace for strings, or dot append for lists, dot index. And those are the attributes. What's the problem with this one?
That the value they should be column.
After this one?
Yeah.
No. That's not the problem.
The listers are the numbers. So this is not possible to copy.
Yeah, that is kind of the answer. More specifically, dot capitalize is something you can do to strings. So if you have a string, you can do dot capitalize in Python also. Test list is not a string, it's a list. List has dot append, dot insert, dot pop, dot remove. It doesn't have dot capitalize. So for this, Python will say, I don't know the attribute capitalize. Lists do not have attribute capitalize. Yeah? So attribute error will be the name that you get with some explanatory text, but the common denominator is attribute. What's the problem about the second one?
Index EW.
Double E instead of one. Yeah. So in this case, we know lists have the attribute index. We just make a type. So for us, these are very different kinds of errors. This one, it doesn't exist. This one is a typo. Python will just give the same error. Attribute error. I don't know this attribute. Index and key error, that one you get in red if some index or key does not exist. What's the problem with this one? That's right.
Oh.
That's right. That's a smart move.
I think attribute number 3 is not existing in the 0, 1, 2, 3. It counts just like that, so
Yeah.
number 3 is not in the list.
What is the final one?
2.
Yeah. So and that's not called attribute. That is the index.
Index,
Yeah, exactly. So that's an index error. You will get an index error, and it will probably say index out of bounds or out of range, something that will be the explanatory text. But in a red, you will see index error. Malet, you try to get item with index source, but there is no item with index source because there is only 0 and bullet. Huh? But generally, yeah, 0 no. Sostenia, bullet no. There is no source. Similarly with this, -9, there is no -9, there's only -1, 2, 3, 4, 5. So index out of bounds, index error. So if you see index error, probably you make some mistake with 0 or 1, or you just let your loop run too long. Then there is name error. That one you have all seen already, maybe you did not realize, but name error you just get if some name does not exist. What's the problem with this?
L.
Capital L. Yeah, you define it with capital L and then you try to use it with small l. This one Python will say, oh, how about it? But it will say in red name error. If you see name error, there are typically two possible reasons. The first one is you simply did not yet define it. You are, for example, running this code, but you forgot to run everything before it. So here you use group names unique, but you forgot to run the part in which group names unique is created. Yeah? You just forgot to define. Second common reason is you make a typo. You use a capital way and actually small letters used. To avoid the typos, often use tab. Yeah? You can just type TE tab and it will fill automatically test list as Python. But name error, then you know it is not yet in the variable explorer. Okay? There is also some general syntax error, and that is just Python does not understand what you are trying to type. You are simply not using the correct syntax. What's the problem here?
Plus sign has to come first before 3.
I don't know actually. Whether that's enough. Yeah, I think that would solve that. Yeah, that's allowed. But more generally, maybe accidentally I hit a plus here. Huh? That happened already with a couple of you. Accidentally you added some character in there that should not be there. You can only have 3 plus something. But indeed, it's a smart move. You are allowed to do it in front because you can also do minus 3, so you can also do plus 3. Yeah, but anyway, 3 plus, that is a syntax error because syntax error, invalid syntax. Yeah, and usually it also points out a bit where the problem was. So somewhere here, check out. Python does not know exactly what you meant to do, but it tries to help you. What's the problem with the second one?
Bracket.
Bracket, exactly. You open with a square and you end with normal. Yeah? Next, the next module will see the use of normal brackets. So it's allowed to use normal brackets, but then it will not be listed of the data necessary. But it's never allowed to start with one and end with the other. Yeah, and a very common one, a very specific one is you get syntax error and then the following text EOL while scanning string data. If you read this, then you know you forgot to close your string somewhere. So if, for example, you have this, syntax error, EOL while scanning string literal. EOL stands for end of line. In other words, Python looked through the whole line and it reached the end of the line before the string was closed. That's not possible. Huh? Before the end of the line is reached, the string should be closed.
Yeah.
Huh? So that's what it's saying. End of line was scanning string method. Here Python knew, okay, the string starts, but where does it end? Huh? Spider helps you a bit by showing you strings are green. So here you directly see, oh, this is still green. That should not be the case. I probably forgot to close it. The add to here should be the string. Okay. Yeah, so the green helps you a bit. But more specifically, this is also a syntax error, but this text points you to, okay, the string Jira. I should close it. You can also get a type or value error, and then you use the wrong type of value. What's the problem with this one? The problem is type error. And then here the text starts to explain it a bit better. Can only concatenate, combine string to string. You're doing here string plus an integer. That's not possible. Yeah, we saw that last week already. So that's a type error. You're mixing the wrong types. If you want to combine them, they should be of the same type. So this one should be a string. For example, string and string is allowed. String and integer is not allowed. What's the problem of the second one?
The top one is a string.
What did the function int do?
Integer.
Turn it into an integer. We saw last week you cannot turn not numbers into integers. If it's some text in there, you cannot turn it into an integer. So you get an error. It will be something like not able to turn string into decimal place 0. Is it? But the common word will be type error or value error. I forgot. Value error. Yeah. So for some reason you are using a wrong value here. Yes, those are the most common error types. Mostly when you get some red, it will be one of these. Yeah? And the more you start to recognize, so do not directly get afraid of errors, no, just start reading them. And if it's a totally new error for you, copy it into Google and find out min eine error. But most of the errors are quite simple to solve. Probably you forgot a colon somewhere, or you added a plus somewhere where it should not be, or you forgot to close your string. Yeah? And the more often you run into error, the better you learn from it. Yeah. I want to already summarize module 2 for you and then introduce assignment, and then I think show still one example. Summary of today. With the keywords that was this morning, if and even else, we can include code that is only executed if some condition is fulfilled or not. Column. Loops help us to do something multiple times, multiple iterations. While loops do something while some conditions do keep on doing. For loops do something for the length of some sequence, and every new iteration, the variable will become the next element of the sequence. Now we can control our loops and ifs with break and continue. Break is stop loop entirely, cut L, mallet, jump to the next loop, skip whatever you are doing. We can put ifs in loops, in ifs, in loops, nesting. You only need to take care that you are doing your indents correctly. If you have an if statement here, anything belonging to that should have one tab. If that happens to be a loop, anything belonging to that should have two tabs, of course. Yeah? So just mind your indents. Now there are many types of errors and not all of them produce error messages. Good. Yeah, I think this is the most relevant. For module 1, there was also some combination assignment. Similarly, this is for module 2, a combination assignment. Applying combinations of conditions and loops, and that is with some air temperature data. Air temperatures from 4 AMO countries. In your folder data, there should be the file m2temperature.csv. And in Spyder, you can open the file m2assignment3.py. Let's just do that. M2 assignment 3. I think this is you guys. Let me quickly show you what data we have used. And two temperatures. It's the following data. For Hamza Ken, and this Ken Hamza, there is data for Arate campuses, main channel good formation, the air temperatures, and Arate air temperatures for Arate campuses. Now, our goal with this data is to get for each campus the average temperature. And you can do that exactly the same as that we did with our average grades. Get the unique campuses, main channel good formation. And then for each campus, look through the list, take only the temperature belonging to that campus. And if you got them all, take the average. That's the idea. However, there are a couple of problems, two main problems with the data. The first main problem is
Naming.
naming, exactly. Because for us, main and main are the same, but for Python they are entirely different. And so that is something we should solve first. We should make sure that this one, this one, this one, and this one are all the same. This represents data collected by different students, and each of them entered the data a bit differently. And so this needs some cleaning. Second problem is we cannot directly calculate it. Because this is a string and not simply a string that we can turn into an integer. It's a string with some annoying text to it. Now to solve this, to clean this data, you can do that with the tools we saw last week. Check what the string starts with, remove capitals within a string, remove some part of the string. Last week we removed spaces. We can also remove space, G-C. And not only do that for this, but do it for all of them. In other words, use the tools of module 1 and put them into a loop. That's what the assignment is about. So, what we can do together is we can run the part load data, F9, and that gives you a list of locations and a list of temperatures. And after that, you can run getting a list of individual locations. So here happens exactly what we did with the group names. Loop through all bulleted locations for E in location. If it's not yet in location list, append it. If it's a unique one, append it. Now the problem is, it now appends main, but it also appends main campus. And so here, if we check all unique locations, it still has main campus, and main. It also has Chamo campus, Chamo, and Chamo. Now, for main campus, I will show you how to solve, and I hope that you will see the principle so that you can, in your own time, practice with this on yourself. Our goal is to change everything to that is main campus. We want to turn it into main campus. So what we can do is, I need to think for E in range length of location. If location if what is the if we focus on main campus, and one, what have these three in common?
M,
M,
M, M, M, A.
M. Okay. So we want to find all the ones that start with MA, we want to turn into main campus. All the others we want to do nothing. Now, there are a couple of ways to do this. We will put it into a loop later on, but let me show it to you for the first one. If location 0 is main. So let's say location name is location 0. Yeah. Now, location name is going to be main. What we can do firstly is location name dot starts with, and that's one method. We can check, does it start with MAP? That's true. Every time that this is true, we only we can change it into main campus. Now there's only one problem. This one. Does it start with capital MAE? So still it does not solve everything. So what we should actually do is take location name lower dot start with MAE. Let me show you what I mean. Zoals de main campus Negrada. We have main. This will go through. We also have main campus. Also goes through. We also have main. Also goes through. We also have full phone. What will that give? Exactly. In other words, we find a nice test to, if we loop through everything, if that one is lowered and then starts with MAE, if that is true, change it into main campus. Change it into, make it homogeneous. So that's exactly what we can put into a loop. For E in range and location, hoe letten we de location names alle? Amsa Ken, Arate, Bota, so hoe letten we ook deze min location? So loop from 0 is coming to then we say location name is location 0, location 1, etc. Then if, then exactly this, location name lowered starts with main, then turn location E into main. Right. These are tools we saw today and last week. Tools of today are the for loop, loop through all locations. And if. The tools of last week are lower everything and then do a test on it. Now that will give a true or false, just false. If this is true, then apparently it's the one we are interested in for main campus. So then turn that one into main campus. And that's also something we saw last week. A list is very flexible, so we can just say list put a 0, I want to know what main campus. No, turn it into main campus. List put a Semanya, I want to know what main campus with capital. No, turn it into main campus with O. So this is combining the different tools we saw from last week, and in this way we are solving cleaning it. So if I will now run this, and run this again, then indeed there is only main campus. Similarly, I hope you realize that exactly the same you can do for Kuvo, Xaml, and Message. Copy this and check that it's set with Kuvo. If so, change it to Kuvo. Does it set with Neck? If so, change it to Visit. Visit. Good. Now the second problem, how to remove the degree Celsius. I let you puzzle on it for yourself, but it has to do also with something you already did by the You can remove the spaces by using replace, so you can also remove space degrees Celsius by using replace. And something that we saw by the And in this case, you want to do it not only for the first temperature, you want to do it for all temperatures. So you want to loop through this list and each time remove this part and put it back. Okay, that was the introduction to assignment 3, which you can do on yourself at home. If you can always ask me questions about it, of course, when you don't get it. Then finally, for today, I want to move into example 6. That's the final thing of today. And for that, I want to point out the for. With a for loop, you can loop over anything. Yeah, so far we mostly looped over a range, code range, and we changed I from 0 to 1 to 3. But you can loop over anything. So for I in range 20, let you loop over 0 up to and including 90. For I in 12, 15, 18, let you loop over these code range. So if we would have this list, my list with this word loop, I loop over the different, and we would use for E in my list, print E, print I. Then Majumari iteration, I will be loop. Bulletin iteration, I will be this one. Sustain iteration, I will be this one. And this principle we can still use in example 6. That's the final example of today. So move back to M2 grid. So I'm looping of the contents of the list. The goal is exactly the same as example 4. We want to get an average per group. Only we are going to do it now a bit efficient. I put them next to each other. This one is from example 4, this is example 6. This code is more efficient. In example 4, we have for I in range length group name unique. And then we say group name is group name unique I. Yeah, so we let I range over 0 as I as Sabat. And then Majumari iteration we get group name unique 0. which is G02. And that we store under group name. So we loop over 0 as Esteban, and then we use 0 as Esteban to get something out of the list, G02, G03. Instead, we could also directly use G02. Why loop over 0 as Esteban if we can also loop over G02, G05, G05? And that is what happens here. For group name in group names unique. Two important things about it. I'm not using I anymore. This I often is used, it stands for index. But you are allowed to give this any name yourself. And this can be J, this can be K, this can be hello, visit. It doesn't really matter what this name is. So we can also, instead of I say, no, it will be group name. We're going to make a new variable group name. What will this group name be? It will be each time the next item of group names unique. Magia item in group names unique is G02. So Magia iteration group name will be G02. Here Magia iteration, I is 0, we use I to get G02. Here Magia iteration group name directly is G02. So this code is more efficient because we use the fact that we can loop over elements. If you use the getter to get something out of the list, realize you could also directly get it out of the list. So this will do exactly the same as this. This is simply more efficient. Well, I let you sleep on that. This one will come back in module 3, so it's no problem to skip this. This is one way to still stick to this surface set. Yeah. So quickly about assignment 3. The getting unique locations part is some capitals, other times not, sometimes complete, other times not. That you now know to solve. Loop through the list location and every iteration change the name to however you want it. With location averages, problems that temperatures are currently strings, and there are some characters because of which we cannot simply turn it into floats. So loop through the list temperature and in every iteration. Change it to a float. Remove the part space degrees Celsius, and then the remaining could turn it into a float. Or you can puzzle yourself on that. It should be with the methods you learned so far. Good, that concludes model 2, but I hope you realize that it simply only becomes clear and that you will internalize it if you practice. Yeah? Practice is up to you, it's voluntary, but if you don't practice, it's a waste of our times. At this moment, I do not yet know when module 3 will be, because Anand and Sol were on break, so I will probably start a new Python training later on. And at first, Selassie Sol registered, but for some reason only Azamis showed up. So Azari said this so next week I will not give module 3, but instead I'm going to communicate with Institute Beoefend Métier de hele software training. So the coming week, Bians, use your time to practice and let me know if you have any questions. And